Welcome everyone to this lesson about the regression analysis. So what is the regression analysis? Regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. In other words, it is a statistical process of estimating the relationship between a dependent variable and the independent variables, and we also call the independent variables predictors because they might use to predict the dependent variable. Let's assume that we need to examine the factor that associated or have relationship with our sales volume in the company. Based on this assumption, sales volume is considered as a dependent variable because it may be affected by other variables. Great. Let's think, what are the factors that might predict our sales volume? Price, quality of product, customer service, store location. We can think of many other factors that might have relationship with our sales volume. What we call these factors in regression analysis? We call them independent variables or predictors because they might be used to predict our sales volume. How do we know which of these independent variables or predictors are associated with our sales volume, and what is the level of relationship for each predictor with the sales volume? Regression analysis help us to answer this question and find the potential relationship in a quantitative level. How? By analyzing the past data to predict the future results. Let's take this example. Let's say you own a car dealer company, and let's assume that your sales volume equal Y. What do you think that the factors that might affect this volume or have relationship with this volume? Price or X1? What are other possible factors or variables that might have the sales volume, have a relationship or affect the sales volume? Car model or X2? Year or X3? Mileage or X4? Do all these factors have relationship with the sales volume? If they have, is that relationship equal for each factor? We are not yet sure. Each one of them might have different level of relationship with the sales volume, or they might have, or might have not any relationship with that variable. Let's assume that the level of impact or relationship is equal B. So, for X1, the level of relationship is B1, and for X2 is B2, and for X3, B3, and so on. We call B1, B2, B3, and Bn coefficients. The value of Y might be affected by the combination of all independent variables. So, by using a simple algebra formula, sales volume Y will be equal to B1 times X1 plus B2 times X2 plus B3 times X3 plus Bn times Xn. Regression analysis uses the observation data to estimate the coefficient values of B1, B2, B3, and Bn. And once these values are estimated, they will be used to find sales volume using this formula that we mentioned here. But the predicted value of Y using regression model doesn't exactly equal to the real value of Y because it is an estimated based on the past data. So we call the predicted value in this case Y hat. There's a small hat on Y. So instead of saying y, we will use y hat. We say y hat is equal to b1x1 plus b2x2 plus b3x3 plus bn xn. So the real value of y in this case will be equal to y hat plus minus the error. And this error will correct any difference between y and y hat, either in minus or in plus. And let's say that our regression model found that there is not significant relationship between x1, x2, and x3 from one side and y hat on the other side. In other words, the value of b1, b2, and b3 are very small or close to 0. So in this case, we say that there is no significant relationship between let's say the price, location, and any other factor with the cell. Okay, so in this case, b1, b2, b3 will be very small or equal to 0. In this case, our y hat or cell volume will be close to 0 based on our formula, because we say the x1, x2, and x3 are insignificant, or the values of b1, b2, and b3 are very small or 0. The coefficient here could be very small or 0. And finally, instead of getting the right value of y, we'll get something very close to 0 in this case. So this kind of a problem that might happen here, because we already have sales volume in our data observation. So the regression model is telling us that sales volume is almost 0 or very low, while we have a sales volume in thousands. So how this problem can be corrected or fixed? This problem can be fixed by add something called b0. We call it also intercept or a constant. We add this to our regression formula. So in this case, it will be b0 plus b1x1 plus b2x2 plus b3x3. So what is the meaning of this intercept or the constant comparing to other coefficients? In case that all the other coefficients here equal to 0, we will have the minimum cells in this case correctly. So our cells, instead of starting from the 0 level, it will start from something above 0. I'm talking now theoretically just to give you an idea, but I assure you will understand what I'm saying when we move to the next lectures and you see the slope of the regression, and you are going to understand 100%. It's very simple to be understood.